Hey everyone, Wazoo here with another video, and in today's episode we're going to be talking about another fun topic, database migrations. Yeah, I know. It's what you were thinking, right? I guess before we get started on any code, maybe it's worth going through what a database migration is and how it can help our app and why we eventually will need them. So imagine that you are, maybe for now, you're still learning web development, you're still learning Spring Boot or any other server language that you're working with, and you are doing everything on your own local machine. And it's an environment that you can easily blow away and get rid of and junk whenever you need to, whenever you want to jump onto something else, or if you make a mistake, you can easily just get rid of it and start fresh with something new. Now, it gets more interesting when you actually start to release work for others to use. So let's say, for example, that we've got an application, and let's see, we'll just call this, and we've got one in this square. This is your app that people can use. So when you're talking to others or when you're working in more sort of development environments, this is what's called production. And it sounds scary, maybe to some people. It sounds, very serious, and it's not. It's really just it's a space that people can access your app from wherever they are across the internet, which is probably one of the coolest feelings to have when you do any kind of development work. It's kind of exciting that just to hear and see that other people are using whatever it is that you wrote and have made available for others. So you've got an app that people can use, and maybe over here, let's just label this as your local machine. And we as in developers, we often just refer to this as development. But this can be, in today's world, this can be your own local machine. This could be a app container that you're logging into, like something on a remote server that you're just treating as a playground for whatever it is that you're building. So regardless, whatever this is your local machine. Now, again, like what I was saying in the introduction, it's nice and easy to, let's use this as maybe a circle. So a circle will be our database. So it's nice and easy to blow away your local database whenever you want to. You make a mistake, you come up with a different table, you enter some bad data, or you just want to start from scratch because you've decided to go in a totally different direction. Then it's totally easy to just blow this one away and recreate it as you need it. Let's just do this. Recreate it as you need it, and there won't be any side effects. So no one else outside of this box is the wiser that that's what you're doing. But things change when you have something available for others to use online. So if you've got a database here, and suddenly people have started populating it with whatever data you're trying to capture in your app. We've built on this channel, we've built a basic to-do app as well as a blog application using Spring Boot. Take those apps as examples where maybe you've made that available for other people to use on a cloud server. And so people have logged in, they've started logging their own to-dos, or they've started creating their own blog posts. So now you've got data that other people are actively touching, and you can't necessarily just trash it whenever you want to. I mean, you could, but you really don't want to. I mean, you kind of want to keep the people happy that are using your stuff, generally speaking, right? So that's when things start to change. And the other factors that go into change are, for example, again, in our application, you've got let's say you've got a blog post table, and you're tracking an ID and I think a title, and as well as like the body content, right? And let's say the timestamps. So let's say that on your local development side, you've got the same thing set up. You've got a post, you've got an ID, you've got a title, and you've got a body and timestamps. You've got a matching environment between your local dev machine and production. Now, what happens on development when you want to add, let's say, an image? So let's say like a blog post image in this example, or like a thumbnail. Let's just call this thumbnail instead of image. Maybe that's a little bit more representative. So now you've got a situation where your local database is different from what's already existing in production. And this is where the benefits of database migrations come into play. So database migrations is kind of a source control, like a Git for your database. So you can capture states of your database. You don't capture the data that's in the database. You just capture the structure, the schema that your database is composed of. So the columns of your tables, any sequences, things like that is what you need to control, what's important in controlling. The actual data is it's easy to back up that and restore it when you need it. But in order to do anything with that data itself, you need the structure to go along with it, the backbone of what composes your actual database. So I think this paints a good picture, no pun intended, as to what goes on with the database and why it's important for database migrations. The other picture that can happen is not only can you have a different set of code running in production than you do in local development, but where you have several local machines all working on the same code base. And each one of them could be working on different phases of the application. So this is now a situation where you've got one or more other people helping you in your project. And so each one of them have to have their own database instances on their own local servers, their own local environments that they're working from. And so you all might be touching the same table, creating elements that interact with that table. You have to find a way of making sure that your databases and your schema is in sync. That way you can equally share the project between everyone working on the same code base. So I think those scenarios illustrate what the importance of using database migrations are. Okay, so here we are back at start.spring.io. We want to create a new project. So we want to choose the Maven project type, Java, of course, Spring Boot version of the latest, which right now is 3.0.4. And we want to give this a artifact name of Spring Boot 3 database migration with Flyway. I know it's kind of a long name, but it's a little bit more descriptive for our purposes. Okay. And then we want to keep it a jar file, Java 17. And so let's go ahead and add some dependencies. We want to add the dev tools. We want to add the H2. We want to add Flyway. Wouldn't that be handy? And we want to add Spring Web, just because I'm always used to adding Spring Web, which gives us the local embedded Tomcat server. And let's see, we need the validation and the data JPA. So we've got all these dependencies linked up to our project. Let's go ahead and hit the generate button, download the zip file, extract it to your favorite place on your hard drive, and open it within your favorite IDE. And I'll see you in there. So here we are in IntelliJ. I'm using it for this project. Let's expand what was created here, and you'll see that we've got a regular Spring Boot start.io project here. What we're going to do is we are going to take a look at the same models that we created in our blog application, our Spring Boot blog application, and we're going to attach migrations to them. So we're going to go through sort of a sample exercise as to how you would manage and control changes to your objects and your database as you are developing your application. So before we go any further, let's just define all of our H2 properties, all of our database properties in our application.properties. And these are the standard settings that I've been using in just about every project so far. Application properties set up here for supporting our local H2 file database. You've seen this stuff before. You've seen that we allow the H2 database console. Now, the other property that we want to show is spring.jpa.showSQL equals true. So that way we can verify all of the SQL that we're seeing in our console log output, as well as we need to tell Hibernate, the Hibernate layer. In the past, we've been using the create drop flag for this DDL auto property of Hibernate. But now this time we want to use something called validate. If you highlight over it in IntelliJ at least, you'll get some helper text here saying that this flag will validate the schema and make no changes to the database, which is what we want. So we want to make sure that during startup, Java Spring Boot will go through the process of having Flyway take a look at our existing database and check for any changes and alert us if anything is different from the last time that it's been used. And I'll show you how, as we go through this, I'll show you how this is done. What we want to start with is in our resources folder, we need to create two subfolders. So we need to create a new folder called DB. And then within the DB folder, we need to create another new folder called migration. And this is a convention used by Flyway. This is the default folder tree that Flyway will check for any migrations that you might have for your project. So what we want to do is we want to create our first migration. Let's say we have back in our application, let's create a new package called models, as we do. And let's create a post model. So here we are creating an entity and a data. We know from our other project that we've been working from, we've got an ID that's a long, and we've got a title. Okay, so we've got our basic post model set up here. We've got an ID field, which we're using as the primary key, using the annotation at ID. We've got a title, and remember how we had the body text. And there was a special definition that we gave it of text because it's basically just a blob of text. So we've got these three properties in our post model so far. So what we can do in our very first migration is we want to create a new table. We want to create a SQL file and then create our table within that SQL file. So Flyway uses a convention where we begin any migration file with a capital V, and then the version number, and then 2 underscores, and then whatever description you want to give that migration. So for example, in this case, we'll be using V1 underscore underscore, and then create post table.sql. So what we want to do is write some basic SQL here. So create table if not exists, and we're calling it post. And then our ID field is a big int, not null. Whoops. We're using the auto increment, and it is our primary key. Then we've also got a title, which is a varchar, and we'll give it a length of 255. I know we haven't really specified that before, but in this case, we'll give it a length of 255. It's also not null, so every blog post needs a title. And then our body. So in this case, I'm just calling this a varchar of a length 5,000. And then we end it with a semicolon. And so this is our first migration that we apply with Flyway. So let's go ahead and start it up, and I will show you what shows up in the log. That everything seemed to start up correctly, and we will go through the log messages. Okay, so first we've got our database pool starting up, and we've got our H2 console available, and then we've got the initialization of our Flyway module, which is, as of this recording, it's the Community Edition 9.5.1, and we've got our database set up here, and then Flyway has picked up that first migration that we've set up. It's created the schema history table, and it's it's run that migration of version 1. So let's go ahead into the H2 console portal and check out what is being created by Flyway. Let's go to localhost 8080/H2 console. And let's blow this up a bit. So if we log in, okay, we now see that we have our post table set up, which currently just has the ID, title, and body. And we've now got a new table here called Flyway Schema History. So if we take a look at that, we've now got a table that tracks the different migrations in our database. So we've got our description, which is what we've given it in the file name, which is create the post table. We've got our version number of 1, and we've got the name of the script, and then we've got what's called a checksum, along with a who installed it and at what time it was installed, etc. So the checksum is the important one, because what's going to happen now is we are going to stop the server and we're going to make a change in our object model. And now what we want to do is we want to go back into our model and we want to add the timestamps to our post entry. So we want to do a local date time of created at and a local date time of updated at. And so now if we run it, I'll just show you what happens. Okay, so we've got a halt in the execution and we've got a whole bunch of logging showing up. And then we'll have a message here. So schema validation, we're missing a column created at in table post. Okay, so it tells you what the error is. So no problem. So what we're going to do is now we're going to add another script, another migration script, to add those timestamp columns to the post table. So let's go ahead and let's shrink this down so we've got room here to work. So back in our migration folder, let's create a new file. And this time we'll call it v2 __ add _ timestamps to post table SQL. Okay, and so what we're going to do is some basic SQL here. We're going to alter table post, add created at timestamp, and then alter table post, add updated at, and then we're using the timestamp keyword. So that's all we should need. So let's go ahead and run this again. Okay, we've started everything up, and let's go back into our logs, and now we see migrating schema public to version 2, add timestamps to post table. So now we've got our timestamp columns showing up in our post table. Let's go back and look at the H2 console here. Let's refresh just to reset it. Let's log in with password. And we'll take a look at the post table. And look, we've now got the created at and updated at. They're empty for now, but they're given a field value of timestamp, a field type of timestamp, sorry. So one last property that we need to add to post is we want to make a use of a sequence, which is how Hibernate juggles the generating of our ID values. So back in post, remember how we have an annotation here called generated value, and strategy equals generation type sequence. Okay, so this is what Hibernate uses to track the IDs of newly created post models. So let's go ahead and let's stop and start this again, just so I can show you the output here. So now we've added this new field since our last migration, and it blows up again. And we should see in the error, let's scroll all the way to the right. So schema validation, missing sequence, post sequence. So let's add that sequence to our post table. So again, back in our migration folder, let's create a new script, and we'll call it v3 _ add sequence to post table.sql. Okay. And so it gave us a hint as to what kind of sequence Hibernate, like the name of the sequence that Hibernate was looking for. So let's create a sequence, post seek. So start with 1 and increment by 50, min value of 0, and max value, and I just gave this one a lot of 9s. So we've now got our add sequence SQL defined. So let's go ahead and run that. And it should start everything up without any issues. And again, if we look back in our log, we've now migrating schema public to version 3, add sequence to post table. So now we've got our sequence set up to manage the auto generation of IDs whenever we need to. So let's go ahead and let's check the database again. It's a lot of refreshing of this database. Password, and let's look at the sequences, and we've got a post sequence right here. So perfect. Everything is going along so far. So now we move on to something a little bit more trickier, and that's when we have relations between databases. So we know we've sort of covered how to do many-to-many, one-to-many relationships in our Hibernate annotations. So now we're sort of more looking at it from a database SQL level. So let's go back to our project. We'll stop it here. And what we want to do is we want to add our authority table. So in models, let's add a new Java class, and we'll just call it authority. And it's also a entity and data annotations. Okay. And we only have one property here, so this is our ID. And our column is length of 16, just for our example case, and string name. So that's the name of our actual column, and we've named it our ID. So that's basically our primary key. Okay, so if we run this as is, we're going to get the usual alert that we're missing the authority table. So instead of running this and then stopping it and going back and creating the migration, I'm just going to go ahead and create the migration right away. So again, in the migrations folder, create a new file. We're going to call it v4__, and then create authority table.sql. And then we're just going to use create table if not exists authority. And then we've got a field or column name of name and length 16, and it is our primary key. Okay, so if we go ahead and run this, everything should run hunky-dory. Okay, good. So, okay, now what we want to do is we want to create the account table, which is just a way of tracking all of our account information. So basically our username, email, password, that kind of thing. So let's go ahead and we'll create in our models folder, let's create a new Java class. We'll just call it account. And again, we'll give it the annotation of data and entity. Okay, and then what we're going to do is we're going to again use the ID annotation, the generated value of strategy equals generation type sequence. And then that's going to be a long. And then we want to capture the email, the password, and then we want to capture the first name and last name fields. And then we also want the timestamps. So local date, time created at, and local date, time updated at. Okay, so similar to our post model. So let's go ahead and create a v5 migration. So in the migration folder, create a new file, and we'll call it v5 create account table.sql. Okay, so create table if not exists, and then account. And then we've got remember our ID is a big int, not null. auto increment primary key. Then we've got an email, which I'm just using a varchar of length 255, not null. We always need an email. We always need a password. So password is varchar 255, not null. And then we've got first name, varchar 255, and a last name, varchar 255, and then our created at timestamp and updated at timestamp. Okay, and then we've also got a sequence for our ID, similar to the post table. So let's create a sequence, account sec, and then we're going to start with 1, increment by 50, min value of 0, max value the same, large number of 9s, and then cycle. Okay, so we've got our sequence set up here, which matches our ID auto increment that Hibernate will use when working with our account model. So let's go ahead and let me just double check our, okay. So let's go ahead and start it up. Let's make sure everything starts up. Okay, everything looks all right. We didn't get any errors, and it should have run the 5th. Here we go. Migrating schema public to version 5. So now our schema is on the version 5 script of our database. Okay, so now it is time to add the relationship between the post and the account. Okay, so in our account model, in the Hibernate world, we have got a one-to-many relationship with posts. Okay, so we're using a list of posts, and we're calling this relationship posts. And then back in posts, we are creating a many-to-one relationship back to account. So let's go to the end here and okay, so we've got a join column. We've given it the name account ID, and we're referencing the ID field of the account table. Okay, so now if we run this, let's just see what error we get. So remember that an account can have one-to-many posts underneath that, or created by that account. Okay, so let's go to our, is this our validate? Yeah, here it is. So missing column account ID in table post. So that is our hint on the migration script we need to run next. So in the back of the migration folder, let's create a new file, and we will call it v6 __ add account ID to post table .sql. Okay, so we can alter the table post, and we want to add the account ID column as a big int. And we need it, so we're just going to call this not null. So let's go ahead and start it up. And everything looks like it started up okay. So now what we also have a many-to-many relation between account and authority. So if you remember back in our account table, our accounts can have multiple authorities. So account can be like a role admin or a role user, and a role user. So underneath this posts one-to-many mapping, we have a many-to-many mapping. So this is where we're using our many-to-many Hibernate. Okay, we're using our many-to-many Hibernate annotation, and we're creating a join table called account authority. We're using the 2 columns of our account ID and authority name to make that join table, which we are then linking back to this account model. So if we run it, it's going to say, the validator is going to say that we have a missing table account authority. So let's go ahead and create that migration script right now. So in the migrations folder, let's create a new file again, and we will call it v7 __ create account authority table.sql. And again, we'll use the create table if not exists account underscore authority. And we have one column which is called account underscore ID, which is a big int, not null, and it's our primary key. And then we have another column called authority name, which is a varchar 16. Okay, and that should be all we need to set up that ManyToMany so that the many-to-many relationship is set up correctly. So let's go ahead and restart the server. And I don't see any errors. There are none. Okay, everything looks like it started up okay. So let's talk about rolling back. So in the process of creating migrations, there's usually a case where you run a migration and then you realize that it was run in error, or you want to change something and you want to get rid of what you just ran, the migration you just ran. And in database migration speak, this is often called a rollback. So we want to roll back the recent change that we've put in place on our database. So with the Flyway Community Edition, the ability to create a undo script, which is what basically you're undoing a migration that you've run, that's only available on the paid version of the Flyway package. So in our use case, what we're going to have to do is create a new migration script, which just basically rolls back what we want to roll back. So let's go ahead and let's create something that we want to roll back. So in our migration folder, let's create a new migration here, and we're going to call it V8 underscore underscore, and then just add accounts. So we want to add some accounts to our database. Okay, so we've got some SQL here. So we're going to insert into account, email, password, first name, last name, created at and updated at. And then we're going to use values of user1 foo at foo.com, password, and then user1 is the first name, foo is last name, and then the current timestamp for the timestamp fields. And we're going to do the same thing with user2, password, user2, etc. So let's go ahead and run this, and everything should start up normally. Okay, it does. And then so let's go back in our H2 console and let's take a look. So we should have two users in our account table, 2 accounts in our account table. So now we suddenly decide, we've run the wrong migration script, and I don't actually want any users in this table at all. So because we're not using the premium version of Flyway, then the only way really to fix this is to just add a new migration. So to the migration folder, let's create a new file, and we'll just call it v9 underscore underscore delete accounts .sql, and then just a simple delete from account. So this will delete everything in that account table. So with the free version of the Flyway package, this is about all we can do. Okay, so now when we go to our table, let's log in and let's check our account, and we've got none here. So the net result, even though we've added some accounts by mistake, is that we were able to roll them back with more SQL. Again, if you had the paid version of Flyway, then you can do what's called a rollback and roll back the current migration that you applied without needing with a proper history being tracked by Flyway itself. And that's it for today's episode. Yeah, I hope you found this little project we put together for database migrations useful, and it gave you some insight as to how important they can be in any project. If you liked what you saw, just give this video a like, subscribe to the channel for notifications on more projects like this, and I'll see you in the next video. Take care, everyone. Peace.